So the next set of questions on this paper, so we're going from 5 to 10 now. It says shade 2 lozenges to show which statements are true about ROM. In the context of this, remember that ROM means read-only memory, okay? ROM is memory that cannot be changed in the computer, all right? RAM is stored where all of your frequently used applications are, yeah? Sorry, that's the cache, but RAM is where you run your operating system and your applications and all of that, okay? So, let's go down these one at a time. Desktop computers usually store application software in ROM. No. Desktop applications are stored in the RAM. It's not that, okay? Desktop computers typically have more ROM than RAM. No. Alright, ROM is a small chip. You hold your BIOS in it. It doesn't need a lot of detail. It doesn't need a lot. So just make sure you understand that. ROM is commonly used for your startup, aka your BIOS. Yeah, alright? ROM is non-volatile. Yeah, ROM is always there when you start the computer back up, okay? So you should have got that. Alright? ROM is used to increase the quality of graphics, definitely not. Alright? So, now, on this question, I think a lot of you may have missed details on this, okay? Let me just draw a diagram to help you, right, think about how this works, alright? Here's the inside of my magnetic hard disk drive, alright? What you've got, alright, is you have multiple platters. On the surface, it looks like this. But there's multiple platters, okay? Remember, you have a read-write head that reads each of these sectors on the top of the surface at such a high rate, magnetizing them, polarizing them, positive and negative. And it's that positive and negative effect that says whether there is a 1 or a 0 on there. Okay? So in terms of what that looks like, okay, first of all, hard disk drives, alright, so you get a mark for mentioning that hard disk drives have multiple platters. You may have said disks, they will accept. Alright? You may have said, well, let's describe what did I say happens? It's a really easy mark, but you might not think to write it. What happens? Does it just put the read-write head on top of it? Yeah. But what happens? Because but what happens? Think about it. If that is my let me think of so if that's the top of my hard drive, what needs to happen in order for that read-write head to actually do something? Thank you. Such an easy mark, but you might not have thought to write it. You got it because it does say explain how. Right? That's got a spin. All right. All right. The disks spin. All right. What you don't realize is that each platter is divided into sections. All right. I know that was a CD that I just put in there. That's optical, but I was just trying to demonstrate what a platter is, okay? So, spun at high speeds. You could have got a mark for saying that data is magnetized and polarized. Magnetized or polarized, however you want to describe it, in regions on the disk. Alright, data is read one block at a time. Read at one block at a time. All right, and data is transferred via cable. These are all the things that you may neglect to write about, but it does say explain how. All right, so I'm just going to go on to the next question now. All right, which asks us what the different gates are. So we're going to start here. What we've got is this gate, and this gate. All right. We don't have the rules yet, but the best way to remember this type of gate is it looks like the last letter of it, a D. Yeah, that's the best thing to help you remember that. So that gate there is AND. All right. I always say that the what's it called? This gate looks like something from Star Trek, like they would wear on their badge or something like that. But that is the OR gate. What can I add to this, just as a bit of practice here, if I wanted to make it exclusive? Exclusive. That means just put a line before it if I want to turn it into an XOR gate. Alright? Remember, the rule of thumb is with an AND gate, both must be true for the output to be true. With an OR gate, it could be true or false. True. It's just one gate needs to be turned on. All right. I could have. I could also have true, true, but I can't have false, false. Okay. So only one switch needs to be true. Any one switch. All right. If it is exclusive OR, I can only have one gate. They're the only conditions that are true there. Okay. Now a NOT gate, all right, will invert the input, e.g. 1 equals 0, 0 equals 1. The reason why I put that as an example there is it really shows your understanding. So if it became a 2 marker, at least you've described that. Or you could have said false equals true or true equals false, okay? For those of you that can't remember what a NOT gate looks like, it's just a triangle with a circle on the end of it. That's a NOT gate. Alright? We're nearly there. I may record this next. Right. Complete the truth table for the logic table. Alright. Apologies the way that I photocopied the papers. I did try and save some paper and take some out. Alright. But let's have a look at this. So it wants you to work out what's what. So if I just put this here, right? Wants to look at what D is with A and B. Okay. So we know that that's an AND gate. Alright. So what is A and B? Is that what? D would be 0. Because that's an AND gate and both must be true. Okay, let's look at this one here. 1 and 1. What's the output going to be here? 1. Okay, now we can go to look at what the output's going to be at F. Alright, what F needs is D. Let's work out E first, because you need D and E to do F, okay? So let's work out what E would be first, alright? So we need to get the output of E, which would be D and C, but you need to follow it through, alright? So if the output of D is 0, alright, so that 0 and C is 0, it's an OR gate, so what's E going to be? Good. Alright. The output of D, alright, is a 1, and C is 0. What's the output of E going to be? 1, because it's an OR gate. Look, output of D was, only one of them needs to be true. It's not exclusive-all. Right, let's look at the last one. Alright, so what I've got here is, I've got D as 1, and I've got C as 1. What's the output going to be there? 1, because it's again, it's OR, it's not exclusive OR, it can work. Now I've got D and E with an OR gate. 0 or 0 is good. 1 or 1, 1, 1 or 1. Perfect, alright? That's what your answer should have been there. Where the marks come from, 1 column for 1 mark, 1 column for another mark, 1 column for another mark. That's what you should have had. I'm going to stop that recording.